Hello and welcome to the API Specifications Conference 2020. My name is Zeke Sikelianos and this talk is called A Swagger Origin Story. So first off, what is Swagger? Well, because this is an API design conference, I'm assuming that most of you already know what Swagger is. But this is an image that embodies what Swagger means to me. It's a physical expression of happiness in the form of a walk. So what was Swagger, the Swagger project? Swagger, which is now called OpenAPI, is a human-friendly and machine-readable language for designing, documenting, building, testing, and consuming HTTP web services. But where did it come from? Well, in 2007, I saw a TED Talk by lexicographer Aaron McKean, who at the time was working for the Oxford University Press, which are the folks who produce the world famous Oxford English Dictionary. And this talk was about how language is constantly evolving and the dictionary is kind of an antiquated mechanism for us being able to catalog all of the world's words. So I thought this was a really fascinating talk. There happened to be someone in the audience, this guy, Roger McNamee, who's a billionaire venture capitalist, and he liked Aaron's talk. So they talked afterwards and managed to start to formulate a business plan, raise some money, and they created a startup called Wordnik. Wordnik was and is a dictionary site at its essence. So it's an aggregator that shows English dictionary definitions for words collected from a variety of different sources. So on this page you see WordNet, Century Dictionary, Wiktionary, American Heritage, etc. But we also called dictionary or word information from other sources like Twitter, Wikipedia, Wiktionary. We collected images from Flickr and news articles from RSS feeds and things like that. So I joined Wordnik in 2011, and one of the most interesting things we were working on there was this concept of free-range definitions. And this was a term coined by Aaron McKean to describe what is essentially the use of a word in context that describes the meaning of the word. So on the Wordnik website, we use lots of example sentences to help people learn how to use the words and kind of glean their meaning from real usage. We also got to work on another really interesting projects at Wordnik. This was an app to crowdsource color definitions where people would see a word and could choose a color that they thought most closely corresponded to that color name. We also made an app for competitive rhyme generation, so people on different teams could come up with rhyming words, and whoever got the most rhymes would get the highest score. And of course, we collected all of this data and used it in the Wordnik API. So the Wordnik.com website was one consumer of the Wordnik API, but we also were designing the service in such a way that it could be used by mobile apps or games or browser extensions or publishers, all kinds of things. We were hoping to be this sort of definitive source for English word data for developers. So we developed a site called developer.wordnik.com, and we listed all of the methods available from our service there. And we also published client libraries for interacting with the Wordnik API in a number of different languages. So I'm going to talk a little bit about what the engineering team was like at Wordnik. So we were a team of lexicographers and computational linguists and web developers, and it was a pretty great mix of people, really interesting time and a really fun group. But we had some cultural differences in terms of the technologies that we preferred to use and how we built things. So Wordnik.com was a Ruby on Rails application with some JavaScript on the front end and some Node.js tooling to build that JavaScript. And API.wordnik.com was written in a completely different set of tools. So our linguists and backend developers were using different languages like Java, Scala, and Clojure, all of which are JVM compiled languages to build the backend for API.wordnik.com. And the API used a MongoDB database as its persistence store. So at the time, legend had it that Wordnik had the largest MongoDB installation in the world, and we had something like 10 gigabytes of data. This was 2011. So the team that was working on that, they were sort of like the thought leaders for how to make MongoDB scale. So I worked on the www team. I was a Rails developer at the time, and we didn't have the luxury of being able to talk directly to a database. So we had to use HTTP to do everything on the Wordnik site through the Wordnik API. So let's talk about databases. Ruby on Rails is a really awesome web framework for building full stack web applications and having fun while doing it. Again, this is the feeling of really learning how to use Ruby on Rails and feeling empowered by it. So Rails uses the MVC software design pattern. I'm not going to get into too much detail about that, but the M in MVC stands for model, and the model manages the data, the logic, and the rules of your application. And importantly, it abstracts away the database. So if you're someone like me and you don't like writing SQL queries, then Active Record is a great thing. Active Record is Rails's object relational mapper that makes it easier for humans to interact with databases. So if you're like me and you don't really like writing SQL queries, especially the kind where you have to join data across multiple tables, Active Record provides this sort of simplified, chainable interface for querying your database, for either pulling data out of it or putting data into it. And Active Record is kind of oriented around simple nouns and verbs and relationships for explaining your data that make it much easier to understand than SQL. So Active Resource is this other Rails project, similar to Active Record. It's an object relational mapper. But instead of abstracting databases directly, it abstracts remote HTTP web services. So if you're building a Rails app and you don't have your own database and you need to talk to some remote API, you can use Active Resource to sort of simulate Active Record-like behavior. Unfortunately, because we were using MongoDB, we couldn't really take advantage of this Active Record sort of style of designing our models in the Rails app. Also, Active Resource didn't really map well to the existing Wordnik API, which if you're designing an API and you want it to work with Active Resource, you kind of need to start from scratch. So this is a snippet from a blog post on the MongoDB website that sort of explains some of the differences between a traditional relational database and the JSON document store that is MongoDB. And there's something in here that's kind of inspiring and sort of led to some of the developments behind Swagger. So this part here says, each JSON document carries its own human-readable schema design with it wherever it goes, allowing the documents to easily move between database and client applications without losing their meaning. And this was really kind of an inspiring aspect of the MongoDB design pattern. So as a Rails developer, though, I still wanted my MVC. I wanted this kind of first-class, convenient way of being able to access data from our Rails application. So we had a challenge, which was, how can our Rails app interact with the Wordnik API in a way that's as fun and intuitive as using Active Record? We had a second challenge, which was, how can we make using Wordnik's API a fun experience for all consumers, not just the developers working on www.wordnik.com. So at the time, this is still 2011, there was an XML specification called the Web Application Description Language, or WADL as it was commonly known. And this is a hint about the origin of the name Swagger. So WADL is perfectly adequate, but our team was not particularly interested in embracing an XML format for describing our data. So Tony Tam, who was the Wordnik CTO and my boss, said, Zeke, why don't you write a basic JSON file structure that describes the APIs as you want to consume them from api.wordnik.com. So we started out with a very simple JSON file that looked something like this, where we listed out all of the paths of the API, and under each path there was an operation. And an operation consisted of an ID and a list of arguments or parameters that could be passed to that. So this was the beginning of Swagger, and we didn't call it Swagger at the time. We still didn't have a name for it when we first created it, but the gist of this idea was that we would have a contract between the developers of the website and the developers of the API, and we could author this contract together and also agree that it was our source of truth for all teams. So the API developers could implement their API according to this specification, and the www developers could implement our client for interacting with the API also according to this specification. We could also generate client libraries in multiple languages, again using this specification. So it was very exciting and really sort of mind-opening moment for us in the history of Wordnik's development. So this, I think, is maybe one of the first API responses that we ever got with the Swagger spec. Of course, Tony implemented the API, and the term here is Tony, and the definition is stylish, high-toned, and upscale, which is very accurate for Tony Tam. So again, back to a waddle. We didn't want to waddle. Waddling is walking with short steps that tilt the body from side to side, reminiscent of a penguin or a duck. We wanted to swagger, to walk with a lofty, proud gait. And at the time, I didn't realize that swagger had this sort of negative connotation of being pompous or conceited. At the time, I was only thinking of swagger as being reminiscent of the baby doing the sweet, happy dance. So I started developing some Swagger logos. This was the first one. It was perhaps a little too smarmy, so we skipped it and went with something much simpler. And I think this one worked better for us because we were able to use Google Fonts website and have predictable font rendering across all browsers. So Swagger UI was kind of an interesting part of the development of Swagger. So one of the things we realized is once we had a JSON specification, we could easily consume that specification and use it to render documentation for our API. So I developed this API listing page that just had a small sort of rectangle, an expandable and collapsible rectangle for each operation in our API. And we somewhat arbitrarily chose colors to correspond to different HTTP verbs to help kind of signal the nature of that action. So we chose red for delete and green for post. So even though that's not a sort of, there's not a whole lot of logic to the color mapping, the color made the documentation a little bit more sort of approachable and perhaps a little more fun for people. We also realized after developing this that hey, because we actually know everything about this API, we could even generate a dynamic form with custom data types um, as a sort of sandbox to try out these API endpoints. So we have this capability on this Swagger UI to, you could put in an API key at the top of the page in a form, and then you could actually start toggling open these API endpoints and interacting with real API information. So we use this not just as a proof of concept for Swagger, but we also use this internally to test our own APIs and do kind of smoke tests to make sure that we were getting the results we expected. So here's an example of how you could get a response body from an API request right inside the browser. So we kind of wrapped all this up. We published it at swagger.wordnik.com, and we open sourced a few pieces of this. So we open sourced the Swagger UI tooling for generating this kind of UI documentation and sandbox. And then we also open sourced a Java-based Swagger code gen tool that was written by Tony Tam and his team to actually generate clients in multiple languages. We also open sourced the Swagger JS client, which was a JavaScript client capable of consuming a Swagger definition file and generating a client live on the fly. So unfortunately, even though we were doing all this really cool open source work with Swagger, Wordnik was not making enough money. We were spending all of our money, and eventually the board of directors got involved, hired some new people, and the company pivoted to being sort of a recommendation engine for publishers. And so there was a thought that we could have a service where you scroll down to the bottom of your New York Times article and there are 3 new suggestions awaiting you for related articles. This to me was a pretty far cry from the original work that we were doing at Wordnik. So, oops. That was a signal to me that my time was over there and it was time to move on to something else. So for me, life after Wordnik was immediately followed by Heroku. I joined Heroku in mid-2012 as a product designer. So I worked on the new add-ons marketplace, which interestingly enough was sort of like an app store for connecting different databases to your Heroku applications. I also somewhat controversially designed the first light Heroku interface, so redesigned the blog to be white, which at the time was a radical choice given that all of Heroku's properties before then had been on a dark background. And at this point I was really getting involved in Node.js pretty heavily and starting to leave Ruby on Rails behind. So I worked on building a new Node.js build pack so Node developers could publish their apps to Heroku much the way that Ruby developers had been able to. And just mostly focused on Node developer experience there. Then NPM Incorporated became a company, and I couldn't resist the temptation to join them. So I moved to Oakland and started working with NPM as a designer and a developer. So there I worked on graphics like this one and created the new docs.npm.js website and helped design and build the new NPM website and package pages. So then after NPM, I moved on to GitHub, and I've been at GitHub now for 4.5 years. First started out working on Electron, which is still very much a Node.js project. Interestingly, Electron's documentation was initially written as markdown files and were completely unstructured. And so one of my biggest projects on the Electron team was to take our unstructured markdown data and parse it into a structured machine-readable format so we could generate TypeScript definitions to be used by editors. So when people are writing Electron apps, they get all that sort of IntelliSense magic that knows how to autocomplete your typing as you're creating an app. So after a couple years on the Electron team, I moved over to GitHub Docs, and kind of set my sights on help.github.com, which at the time was a sort of old and neglected app that didn't really have much design or engineering love given to it. So we rewrote this thing in Node.js. And then we embarked on this effort to merge help and developer.github.com into a single unified docs website, docs.github.com, and that launched earlier this year in 2020. So before we did that, developer.github.com was the home of the REST API documentation for GitHub. So this is a screenshot of one of those API reference pages for listing pull requests. So you can see as a developer, all the information is here. You can see the HTTP verb and the path and all the parameters and all that kind of stuff. But this was difficult for the team internally at GitHub to maintain because we didn't have a schema. We didn't have a source of truth. We weren't using Swagger. We weren't using OpenAPI. So this is a screenshot of what the source API documentation looked like for a REST API. So it's kind of a combination of Markdown mixed with some embedded Ruby mixed with Jekyll templating. So it's kind of like this Frankenstein evolution of API documentation that was unstructured and has sort of come together piecemeal in different ways and created by different teams over 10 years or so at GitHub. So we knew that we wanted to move away from this, and we wanted the API to be described closer to where it's actually developed in the GitHub code base, as opposed to living in Markdown files on the developer site. So side note, OctoKit is a set of client libraries developed at GitHub. So OctoKits are client libraries for consuming GitHub APIs. They're written in several languages. I think at this point, maybe Ruby and Node.js are the only officially supported and maintained OctoKits, but there are a number of others in different languages that are community contributions. So Gregor Martinus is a contractor at GitHub who has done a lot of interesting work to schematize and structure GitHub's previously unstructured API documentation. So Gregor created this project called OctoKit Routes, which essentially scraped the developer.github.com REST API documentation and turned it into a structured schema, very closely resembling an OpenAPI schema. So when I was working on docs, I worked closely with Gregor and some contractors to take this OctoKit routes data, which was being scraped on a nightly basis by robots, and turn it into something more official. So we hired Adam Altman and Roman Hotzi from Redocly, who are experts in OpenAPI development, to help us take our scraped documentation and turn it into a proper OpenAPI definition file. So we've actually managed to complete that process, and as of just a couple months ago, the REST reference documentation now lives on docs.github.com and is powered by an OpenAPI specification. So you can see it's got a lot of the same information that it previously had on developer.github.com, but it's got a few extra bells and whistles. Most notably, we can now generate code samples for different client languages. So we can generate a shell example and OctoKit examples for how to actually copy some code and run with it and use those APIs directly. So this is just the beginning. We're definitely going to expand more on some of the stuff that we display on the website using the OpenAPI definition. If you want to check this out, it's at docs.github.com/rest. And we recently open sourced our OpenAPI description files. So if you go to this repo, GitHub/REST API description, we're publishing the files there. And we're still in the process of kind of moving the REST API description into the GitHub code base so that it can be more integrated into the design process. So when developers are building new APIs inside of GitHub, that they can actually start with a design-driven approach to building those APIs using OpenAPI description files. So last thing I wanted to mention is that GitHub has a public roadmap now, which is really cool. So if you're a GitHub customer and you are interested in finding out what's on the horizon at GitHub and what new features are going to be launched in the next year, you can go to github.com/github/roadmap. And I bring this up because we are open sourcing docs.github.com in just about a month or so. So all this tooling that lives behind closed doors right now to work with OpenAPI descriptions will soon be open sourced. So stay tuned for that and check out the roadmap. And I hope you enjoyed this talk. Thanks for your time. Take care. Be safe. Party on.